Hi, ladies and gentlemen. Now we're looking at tutorial sheet 8, right? Tutorial sheet 8. We're now looking at question 5. Tutorial sheet 8, question 5. Last time, if I do remember, as a recap, we looked at question 1 to 4, right? Of which we ended on question 4. We did an example on sine 225, an example on the positive and also on negative. We also looked at an example when we were dealing with the pi, right? The pi. So remember someone asking in the comment section, what if you converted to degrees, found your answer, then converted it back to radian measure? That is fine, okay? You can do that. Question 4. Let's maybe look at h. Alright, so let's look at h. Question 4h. For h says, find the exact value, use the basic trigonometric identities. So find the exact values. Do not use a calculator or a table for the following. So we have cos of negative 5 pi over 3. Alright. So first thing first, we basically have to first identify where is negative 5 pi over 3. Alright. So where is negative 5 pi over 3? As I said, in radians, this is 0, this is pi over 2. This is pi, then we have 2 pi, okay, let's say 3 pi over 2, and we have 2 pi here, right? So if you are not converting back to degrees, this is how you go about this question. We want to know where is 5 over 3? Where is 5 over 3? Now, if I'm going to look at 5 over 3, I'll divide. 5 over 3 is 1 point. So this is 1, 3 can go into 5, 1 time, remainder 2, okay, then we know it can go into 26 times, so 1.6, basically speaking 1.6, remember this is this is 1, 0.5, this is 0.5, this is 1, this is 1.5, so 1.6 is here, right? So if you are going in the negative direction, and you are looking for 1.6, right? So you are looking for 5 pi over 3. Where is it going to be? Okay. Now, of course, you also take note that this particular angle is actually beyond 360 if you were to convert it in degree measure, right? Let's just look at that. 5 pi over 3 multiplied by 180 over pi, right? So this pi's will cancel. 3 into 180 is actually, 3 into 180 is 6, okay? So this is 60. Then you say 5 times 60 is 300, right? So basically speaking, you have 300 degrees, all right? So if this 300 degrees, but now has a what? A negative. It now has a negative. So you are moving, because of the negative, you are moving anti-clockwise. So where is 300? 300 is like between 0 and, it's supposed to be between 270 and 360, but since we're dealing with pi, it's supposed to be between 3 over 2 pi and 2 pi. But since we are dealing, we are dealing with a negative, so we're moving in the opposite direction. So you're actually looking for an angle here, right? So, basically speaking, that is that. So this is what you are calling negative 5 pi over 3, or 300 degrees, negative 300 degrees, right? So that is negative 300 degrees. All right. So now that we have that, how do we find the value in question? How do we find the value in question? So cosec, cos negative 5 pi over 3 is the same as say negative 300, all right? So negative of 300, but we know that in this case, right, in this case, this is the same as saying what is 360 minus 300, which is just 1, all right? So in this quadrant, we know that theta and alpha are the same, all right? So since this angle is here, which is beyond 360, it's like saying 360 minus 300. So this is the alpha you're looking for, which is 60 degrees, all right? So this, so we're saying, if you're saying cos of negative 300 degrees, all right? Cos of negative 300 degrees is the same as cos of 300 is positive in this, or are positive in here. This is the same as 360 minus 300, right? Which is cos 60 degrees, right? So cos 60 is the same as cos of, this is the same as cos of negative 300, right? So what is cos 60? If you check, cos 60 is actually root of 3 over 2. No, actually, cos 60 is half, right? Cos 60 is half. We'll look at how you can find these special angles because we are making reference to them, all right? So cos 60 is half, so this is 1 over 2. It's equals to cos of negative 300, right? So therefore, we're saying cos of negative 5 pi over 3 is simply 1 over 2, positive, right? So it's positive 1 over 2. That is your answer, right? It doesn't go beyond that. So that is how you find your answer there. Okay? That is how you find your answer. Okay, so next question. Let's go to question 5. Right? Use the basic trigonometric identities to find the remaining trigonometric functions. Use the basic trigonometric identities to find the remaining trigonometric functions. Right? For A, sine theta is equal to 4 over 5 and the terminal side of theta lies in the first quadrant. Right? So, one of the important things you need to note about these questions, right? You need to know which quadrant the question is stating. So you've been told that the terminal side is in the first quadrant. The terminal side is in the first quadrant. So meaning this is the terminal side. So that's the terminal side. All right. So that's the terminal side. Next up, you are told that sine theta is 4 over 5. Now we know that sine theta is actually opposite over hypotenuse, right? So sine theta is opposite over hypotenuse, and we have, this is, sorry, this is 90, right? And I don't really need to write these others. I just want you to know that the terminal side you are dealing with is in the first quadrant, right? After that, you need to find 4 over 5. So, if you've been given that sine theta is 4 over 5, meaning that the opposite is 4 and the hypotenuse is 5. Right, so opposite of the angle is 4, the hypotenuse is 5. Right, so find the other remaining trigonometric identities. Right, we need to find the remaining trig identities. So in order to do that, what we're going to do is we're going to say so 0 sine theta. Actually, what's the missing side? The missing side is the adjacent, right? We also know that hypotenuse squared is found as adjacent squared plus opposite squared. Alright? We have a missing side here. So for us to find the missing side, we're going to use SOHCAHTOA. Okay, so in this case, the Pythagorean theorem. Right? So the Pythagoras theorem is what we're going to use. So hypotenuse is given as 5, so we have 5 squared is equals to, adjacent is what we're looking for, opposite has been given as 4 squared, right? So now we have 25 minus 16 is equals to adjacent squared, right? So 4 times 4 is 16 and it goes that side. So adjacent squared is 25 minus 16, we have 9 root, so meaning the adjacent side is given as 3, right? So this side is 3. Right, so that's how you find that. That's how you find that. Next, but we are not done. We've been asked for the other trigonometric ratios, all right? So now that we know what our opposite, what our adjacent side is, can we find the remaining trigonometric identities? So we have SOHCAHTOA. Okay, so this is what I'm going to make reference to, SOHCAHTOA. So we have been given, we've been taught, remember basic trigonometric identities, those are the ones that we're dealing with. The first one is, we know that sine is opposite over adjacent, right? So sine has been given as 4 over 5. So what is cos? Cos, we know, cos, from CAHTOA we have adjacent over hypotenuse, right? Adjacent we found as 3, hypotenuse was 5. Tan, so we have tan is opposite over adjacent. We found the opposite was given as 4, and the adjacent we found as 3, right? But the trigonometric identities do not end there, the basic ones, right? So the basic ones do not end there, we have to continue, right? So the basic ones don't end there. Which other ones do we have? Which other ones do we have? So the other ones that we have sec. Let me write them here. The other basic ones we have sec, which is 1 over cos. Right, so we know that cos is 3 over 5, so this is going to be 5 over 3. We have cosec. We know that cosec is found as 1 over sine, okay, but we know sine theta has been given as 4 over 5, so this is 5 over 4. It flips, it flips. So we have also cot. Cot is given as 1 over tan, and we know that tan has been given as 4 over 3, so this is 3 over 4. Okay, so those are the basic trigonometric identities which we will have at the end of it all. Right, so that's basically how you go about that question. That's how you go about that question. All right, let's continue. Let's continue. Okay, so a continuation. I'll only erase the ones that are relevant. So we say sec is 1 over cos theta and 1 over sin theta. Okay, so that I can easily make reference to those. The next question says, cos theta is negative 5 over 13, and the terminal side of theta lies in the second quadrant. Right? Cos theta is negative 5 over 13, and the terminal side lies in the second quadrant. Okay. So second quadrant, we're here. We've been given cos theta as 5. Cos theta is as negative 5 over 13. Okay, so meaning if cos theta is negative 5 over 13, what is the adjacent? The adjacent side is 5 and the hypotenuse side is 13, right? Now that negative is simply telling us which quadrant we are in, right? The negative 5, ladies and gentlemen, is just the quadrant. The negative is the sign of the quadrant. Remember that in the second quadrant, only sign is positive, all right? So since here only sign is positive, whatever else which is not sign is going to be negative, all right? So this is why you have negative 5 over 13, because the cos is negative in that quadrant, right? So 13, 5. What is missing? What is missing is the opposite, right? So how do we find opposite? We are still going to use the Pythagorean theorem. So opposite squared is hypotenuse squared. Okay, starts from the normal way. Okay, so the hypotenuse squared is equals to opposite squared plus adjacent squared. Right, but hypotenuse has been given as 13. So this is 13 squared is equals to opposite is what we're looking for. Squared plus adjacent is 5 squared. Alright. Now 13 times 13 is 169 minus 25 is equals to opposite squared. So this is 144. 144 is equals to opposite squared. Take the root there, take the root there. So opposite is actually equals to 12. Alright, so this is what the opposite is, 12. So I'll write 12 here. So I'm saying the opposite side is 12. Okay, now that we know what the opposite side is, can we find sine? We've been told that sine is opposite over hypotenuse. Alright, so sine is opposite over hypotenuse. Opposite is now 12, hypotenuse is 13. Alright. But since we're in the second quadrant, we know that in the second quadrant sine is positive, so it maintains as 12 over 13. Alright, next one is tan. Tan is opposite over adjacent. Opposite we found as 12. What is the adjacent? The adjacent was given as 5. So this is basically going to be its opposite. Opposite is negative 12 over adjacent, which is 5. Why have I written it as negative? It's because in the second quadrant, only sign is positive. So meaning tan is negative in that quadrant, alright? So that's how it works. So in that case, that would be negative in that quadrant. Next up. Alright, so the next part which we have is we need to know what sec is. Now we said sec is 1 over cos theta. So sec is basically going to be the flip of cos, okay? The flip of cos, so it's negative 5 over 13, so it becomes negative 13 over 5, alright? What is cosec? Cosec is going to be the flip of sine, okay? So sine is 12 over 13, so meaning this is going to be 13 over 12, alright? 13 over 12. Then the other one we have cot. Cot is 1 over tan, and tan is negative 12 over 5. Yes, negative 12 over 5, okay? Because opposite was 12, then adjacent was 5, alright? So negative 12 over 5. But we are saying 1 over tan is the flip, so this is negative 5 over 12, right? So that's how we find that. Basically speaking, that is how you go about that question. All right, so let's continue. Let's continue. What else do we have? What else do we have? The next question is saying tan theta is equal to 12 over 5. Okay, for tan theta to be 12 over 5, and the terminal side of theta lies in the third quadrant. So the terminal side of theta lies in the third quadrant. Okay, so the terminal side lies in the third quadrant, so the third quadrant is this one. So the terminal side is that. So here only tan is positive, alright? So since tan is positive and the tan that we've been given is 12 over 5, tan is 12 over 5, meaning that the opposite side, tan is 12 over 5, let me write it here. Tan theta is 12 over 5, meaning that the opposite is 12 and the adjacent is 5. So the opposite is 12 and the adjacent is 5. So now what we're looking for is we need to find the hypotenuse, okay? So we know that hypotenuse squared is equal to opposite squared plus adjacent squared, alright? So hypotenuse squared is equal to what is the opposite? The opposite has been given as 12 squared plus adjacent squared. Adjacent has been given as 5. So we have 5 squared. This is 144 plus 25. So, okay, so root of that, this is root of 169, right, which is simply, so that's root of 169, which is going to be basically 13, right? So we have this as 13. So the hypotenuse becomes 13, okay? So the hypotenuse is 13. The hypotenuse is 13. Now that we know what the hypotenuse is, we can find the rest of the trigonometric identities. Sin theta is opposite over hypotenuse, so opposite is 12. So this is 12 over 13. Adjacent is 5, so 5 over 13. That's cos 5 over 13. Sec is 1 over cos, so the flip side of cos is 13 over 5. Cosec is 1 over sine. The flip of 1 over sine is going to be 13 over cosec. It's going to be 13 over 12, right? And the flip of tan is going to be, the flip of tan is 5 over 12, all right? So 5 over 12. So basically speaking, that's the way you go about these questions, all right? That's just how you go about these questions. Next up, the next question which we have says cosec theta is -5/4 and sec theta is less than. Okay. So I was saying sec theta is 1/cos theta. Okay, so cosec theta is given as -5/4 and sec theta is less than 0, right? So this simply means you know what cosec is, huh? Cosec is there, 1/sin. So 1/sin theta is given as hypotenuse over opposite, or let's just say -5/4. All right. So we know that this is actually 1/sin theta is the same as 1/sin is opposite over hypotenuse, right? So that we have, and this is cos -5/4. If it flips, you have the hypotenuse over opposite being is equal to -5/4, right? So basically speaking, hypotenuse is now -5 and the opposite is 4, right? So that we've also been told, in this case we've not been told where the terminal sign is. All that has been mentioned is that sec theta should be less than 0. So what is sec? Sec theta is 1/cos theta, right, from here. 1/cos theta. So meaning that cos is negative. If it's less than 0, then cos is negative. So in which quadrant is sine negative because of cosec? 1/sin. So cosec is negative, meaning sine is negative. In which quadrant is sine negative and cos negative? In which quadrant is sine negative and cos negative? This is in the third quadrant because they are on internal is positive. So we're saying it's in the third quadrant, okay? So this basically speaking, we're here. Alright, so we are in the third quadrant. So in this third quadrant which we are in, what is the hypotenuse? The hypotenuse is 5 and the opposite is 4. Okay, so what is the adjacent? So we need to calculate for the adjacent side. So we know that hypotenuse squared is equal to adjacent squared plus opposite squared. Alright, so we know that the hypotenuse has been given as 5 squared. Adjacent has not been given, that's what we're looking for. Opposite has been given as 4 squared. So we have 25 minus 16 is equal to adjacent squared. This is 5, sorry, this is 9, it's equal to adjacent squared. Take the root on both sides, adjacent is, we have 3 is equal to the adjacent. Okay. So the adjacent is 3, so meaning this side is 3. Alright, so we have the opposite as 4, the adjacent as 3, and we have the hypotenuse as 5. So let's find the remaining trigonometric identities. Right, so using cosec, because we all started off from cosec, right? So we used cosec as -5/4. We're saying because cosec is 1/sin is negative, So we're looking for the quadrant in which sine is negative and cos is negative, which is the third quadrant. In this third quadrant, the terminal side is given as that. So we had hypotenuse as 5 and opposite as 4. We needed to find the adjacent, which was missing by the Pythagoras theorem. We actually get the adjacent side as 3. All right. So now that we know what the adjacent side is, we can find the rest of the trigonometric identities. All right. So we know that sine theta is found as opposite over hypotenuse. All right. So opposite over hype. If you look at what we're dealing with here, opposite over hype, where is opposite? Opposite. Okay, so opposite is 4, hypotenuse is 5, so this is 4 over 5. But ladies and gentlemen, do not forget that we are in the third quadrant, and in the third quadrant, sine is negative. So this is basically negative, okay? Adjacent over hypotenuse. Adjacent over hypotenuse, adjacent is 3, hypotenuse is 5, so we have 3 over 5, and we still negative 3 over 5 because we're dealing with the third quadrant. Now, what do we get for the other one, right? So to find the other one, which is the tan in this case, tan is opposite over adjacent. Adjacent side, opposite side is given as 4, and the adjacent side is given as 3, so this is 4 over 3. It's positive because this is the owner of the quadrant, right? So it's positive 4 over 3, all right? So that's opposite over adjacent. Sec of theta is the flip of cos, all right? So the flip of cos will be negative 5 over 3. Cosec, the flip of cosec, of course, cosec was given as negative 5 over 4, but if you want to verify, if you flip sine, you'll notice that you'll get back to negative 5 over 4, right? It's negative because we're in the third quadrant, only tan is positive, and lastly, 1 over tan is 3 over 4. It's the flip, okay? 3 over 4. So that is what we get. Those are our values. So that's how you deal with questions of that nature. Right, that's how you deal with questions of that nature. All right, so that having been said, let's go to question 6. Basically, let's go to question 6. All right, so the basic principles we needed here for this question is we needed to know what are these basic trigonometric identities. Okay, the basic trigonometric identities, we said sine, cos, tan. Okay, we can also find their indices. Okay, so if we have sec theta, we have cosec theta, we have cot theta. All right, so ladies and gentlemen, that's that. All right, so apart from that, what else do we need to know? Okay, so we also needed to know what is what in which quadrant, which one is positive in which quadrant, and which one is negative in which quadrant. So we actually discovered, or we noticed that all are positive in the first, only sine is positive in the second, only tan is positive in the third, and only cos is positive in the third. Alright, then we answer the question according to the stated property. In that case, the condition that was given, okay, was the terminal side. Now, you notice that the last question, the terminal side was not stated. All they said was that the sec theta should be less than 1, should be less than 0. So that was enough information to get by. Alright, so that was enough information to get by. That's how we go to that. Alright, so end of that question. Alright, so let's now look at the application of trigonometric identities. Okay, so simplify the given trigonometric expressions to a single trigonometric function or a constant, alright? So when I do question 6, I will not do question 7, it's one and the same concept. Right, so question 6 and question 7 is one of the same concept. I'm just using identities. Okay. Yeah, we're using identities. I'll start from B. Okay, so A has to be reviewed. I'm starting from B. B says cos squared x minus 1 multiplied by tan squared x plus 1. Okay, so that is what we have. Cos squared x plus 1 multiplied by tan squared x plus 1. So how do you solve that? Okay, basically speaking, we have to first remember what tan x is, right? Now we know that sine cos squared x minus 1, right? Yes, this is cos x squared minus 1. We have to remember what the other identity is. Okay, according to your trigonometric identities, 1 plus tan x is actually given as 1 plus tan x is actually given as sec, right? Sec squared x, that is what you have. Alright, so we're going to use that as the property that is going to help us to configure that question. Okay, so as I said, we know what tan squared x is. Okay, so as I was saying, tan squared x plus 1 is the same as sec squared x, right? Tan squared x plus 1 is the same as sec squared x. So this again also, if you intently look at it, sin squared x, if I was to factor out a negative, just from this one. Okay, let's not do that. Let's just say this is cos squared x minus 1 multiplied by tan x squared plus 1, as I said, is sec squared x. Alright, now this sec squared x which you have, if I factor out a negative, alright, we're going to have 1 minus cos squared x, right? Then sec squared x. Alright, sec is 1 over cos, right? This one here is sine squared x. Okay, so negative sine squared x multiplied by 1 over cos squared x. This ends up being negative sine squared x over cos squared x. Your answer being negative tan squared x. Right, so your answer ends up being negative tan squared x. Okay, now take note of this. When I was solving this question, I know some of you would have easily had to conclude. Remember that sine squared Sine squared x plus cos squared x is actually 1, right? Then you can find sine squared x as 1 minus cos squared x, right? It's 1 minus cos squared x, not cos squared x minus 1. So take note of that trick. There was a flip here, okay? It was the 1 with the negative and it was the cos with the positive. So I can factor out a negative. We know that sine squared x plus 1 is sec squared x. Then what I just did was I factored out a negative from here so that this one becomes 1 minus cos squared x, something which you are familiar with. Then we know 1 minus cos squared x is sine squared x, then multiplied by sec squared x is the same as 1 over cos squared x, alright? Which ends up being negative sine squared x over cos squared x, which is negative tan squared x. So that is how you go about that. So sine over cos is tan, so meaning sine squared x over cos squared x is also tan, alright? But the only difference is that now you have the square root of tan. Okay. C. Let's look at C. So cos z plus sin z tan z, right? Right, now C is similar to A. It's actually almost exactly as A. The only difference is that it's similar, okay? It's similar because here you have sine instead of having cos. But now you have sine here, you have cos there. But in this question, which we have, okay, so this is cos, yeah, this is sine, but in that question you have sine, right? So that's the similarities, that's the similarity. Right, so how do you deal with this question? Remember, we've been taught to change this to a single trigonometric function or a constant, right? So it's either a single trigonometric function or a constant. Right, so cos z plus sin z tan z, what do we do? In this case, what you basically have to first note is that we know cos z plus sin z, tan is what? Sine over cos, right? Sin z over cos z, right? If you multiply this times this, you have cos z plus sine squared z over cos z. Alright, now, sorry, the over ends here, cos z over 1, so common denominator is cos z, 1 into cos z is cos z plus cos z, cos squared z, plus cos into cos is 1 multiplied by that, sin squared z, right? So cos squared plus sin squared z is a trigonometric identity for 1, I even wrote it here. So we have 1 over cos z, which is equal to sec z. Okay, so that is your answer, sec z. Okay, next up, right, the next question says, sec y minus cos y over tan y, right? Sec y minus cos y over tan y. Right, sec is 1 over cos minus cos y, then divided by, so let's say sine over cos. Common denominator here is cos y 1 minus, this is going to be cos squared y multiplied by cos y. Remember, division changes to multiplication. Okay, so we now know that 1 minus cos squared y is sine, right? So we have sine squared y over cos y multiplied by cos y over sine y. This and this will cancel, sine into sine is sine y. So this is your answer, right? So sine y over 1, which ends up being sine y. Next, okay, so let's pick f. Cot x over cot squared x plus 1. Right. Now we know that cot x squared, we have an identity for cot x squared plus 1 is cosec, right? So this is cosec squared, right? So we have cot x divided by, or let's just say over cosec squared x, right? So this is a short form for cosec squared x, but we know that cot x is the same as sine over cos, so we have actually cos over sine divided by, we know that cosec x is the same as 1 over sine squared x, right? This 1 over sine squared x, this actually ends up being cos x over sine x multiplied by sine squared x over 1, right? Because it flips, right? So when it flips, this and this ends up being cos x, or let's say sine x cos x. So that is your answer. Sine x cos x. Okay, so that's how you go about solving those things. Next up, G. Okay, so let's go directly to question 8. Let's look at the question on question 8. Question 8. Okay, so question 8, given that sine alpha is, so it's been given sine alpha is equal to 3 over 5, okay, and sine beta over 17, right? With beta in the third quadrant, find tan alpha minus beta Okay, so it says with beta in the second quadrant, all right? So beta is in the second quadrant in this case. Find alpha minus beta and find tan alpha minus beta, okay? And also find tan alpha plus beta. All right, now ladies and gentlemen, you know that tan is also an identity on its own, right? Whenever you're talking about the difference of those two in terms of tan, so we want to write it in terms of tan, right? So the sum and the sum difference, okay? So if you look at the sum difference for these identities, you actually notice that tan alpha minus beta is actually found as tan of alpha minus beta, let me say tan alpha minus tan beta, okay, over 1. Since it's minus, it becomes plus tan alpha beta. Okay, so basically speaking, that's your trigonometric identity in question, right? So tan alpha minus beta is given as tan alpha minus tan beta over 1 plus tan alpha tan beta, right? Now, in this case, what you've been given is sine as 3 over 5, and you know that beta is 15 over 5, okay? So what is tan alpha? So in this case, this sine alpha here, you've been told that beta is in the second quadrant. Let's check where alpha has been given. Okay, alpha in the first quadrant and beta in the second quadrant, right? So alpha in the first quadrant and beta in the second quadrant. So this is what you have there and there. So this angle here is beta, this angle here is alpha, right? So that angle there is beta and the other angle there is alpha. So we know that in the first quadrant, sine is given as opposite over hypotenuse. So meaning that the opposite is 3, and the hypotenuse is 5. Okay, so we can find the missing side, which is the adjacent side. So I'll write it here, or saying hypotenuse squared is equal to adjacent squared plus opposite squared. Right, we have 5 squared is equal to adjacent is what we're looking for. Opposite is 3 squared, so we have 25 minus 9 is equal to adjacent squared, right? Then 25 minus 9 is 16. Root, so adjacent is actually 4, right? So we have adjacent being equals to 4, all right? So it's a principle. We are applying what we did in question 5 on this very principle, right? So we're simply applying the principle on question 5 to find the values in this. Okay, so now here we now know what all the particular sides are in the first quadrant. What of the second quadrant? In the second quadrant, we've been told that sine beta is 15 over 17. All right, now 15 over 17, if you look at 15 over 17, opposite over hypotenuse, so meaning the opposite is 15 and the hypotenuse is 17. All right, so here the opposite is 15 and the hypotenuse is 17. Okay, so we are still looking for the adjacent sides. So if I can write it somewhere here, so we're saying adjacent okay, so we'll refer back the formula later. Here is it. Okay, so here we're saying hypotenuse squared is found as adjacent squared plus opposite squared. I'm here now, right? So hypotenuse there, this is the right angle. Okay, so hypotenuse there is given as 17 squared is equals to adjacent. Adjacent is what we're looking for. Squared plus opposite is 15 squared, right? So we now have 17 times 17. 17 times 17, which is the side we're looking for, is 289. Okay, so we have 289 there, and we have the adjacent side squared plus 225. All right, so meaning adjacent squared is actually 289 minus 225. Adjacent squared is now given as 64. Root, so what is the adjacent? The adjacent ends up being equal to 8, right? So adjacent is 8. Right, so the adjacent is 8. So where the adjacent is, I'm going to write 8 there. Okay. I'm going to write 8. Right, so we have 0, 90, 180, 270, right? So we still have this. Okay, so basically speaking, I'm using a principle, what we learned in question 5, relating it to question 8 before finding the actual trigonometric identity which has been given. Okay, so that having been said, what is tan in the first, what is tan alpha, alright? So meaning tan alpha is, we know it's opposite over adjacent, right? So in this quadrant, what's the opposite? The opposite is 3 and the adjacent is 4. Okay, so tan alpha is therefore equal to 3 over 4. And tan beta, opposite in this case is 15 and adjacent is 8. Okay, so that is what we have. So tan alpha will be equals to 0, is equals to 3 over 4, and on the other side it's going to be 15 over 8, right? But we've not found what we're looking for. We've not found what we're looking for. So how do we find what we're looking for? To find what we are looking for, we don't have to forget where we're coming from, right? We've been asked for tan A minus B. So the question that we have is tan A minus B. Okay, so tan A minus B we said is tan A so this is alpha minus B. Yes, so alpha minus beta. But let's refer back to the actual, right? Tan A, since it's minus tan B over 1, since it's going to be plus tan A, tan B, right? But now we're looking for tan alpha minus beta. This is going to be tan alpha minus tan beta over 1 plus tan alpha tan beta. We've been given tan alpha as 3 over 4 minus tan beta is 15 over 8, okay, over 1 over 1 plus tan alpha is 3 over 4, then tan beta is 15 over 8. Now, ladies and gentlemen, before I even get to the final answer, right, I also want you to note that these figures are not going to be positive, they're going to be negative. Tan alpha is opposite over A, so it's supposed to be negative. The reason why is we're in the second quadrant and their tan is negative, alright? So meaning this is supposed to be negative, and maybe because we're in the first quadrant, this is going to be positive, alright? In the first quadrant all are positive, so even tan will be positive. But for this one in the second quadrant, this is going to be negative, alright? Because we are actually dealing with the second quadrant, and the second quadrant tan is negative. So that this will be 3 over 4, then this will be plus. Okay, so 3 over 4 plus 15 over 8 over 1 plus 3 over 4, then minus multiplied by negative 15 over 4. Okay, so basically speaking, this is how your answer will look like. Okay, so 3 over 4, so let's make this look like a 3. Okay, then we have negative 15 over 4, right? It's not done. So basically the reason why this is plus, this is minus, right? Then tan B is negative 15 over 8, so this is why it's negative, right? So I've simply written that in the standard form. So as we said, if you look at the trigonometric identities, tan is given, tan alpha minus beta is given as tan alpha plus minus tan beta, then we have the flip down there. Now since it's negative, it's going to be 1 plus tan alpha tan beta. Now we know that tan alpha is 3 over 4, so we can actually evaluate that. Doing that, what's 3 over 4? Common denominator there is 8. So we now have 4 into 8 is 2, so it's 6 plus 15 over 8, which is 21 over 8. Okay, so the numerator is 21 over 8. So we have the numerator, which is 21 over 8, and the denominator, since those two are multiplying, so you're saying 1 minus 3 times 15 is 45, so negative 45 over 16. This is the same as 16 minus 45 over 16, right? So 16 minus 45 over 16, that is what we have. So 16 minus 45 is negative 29, right? So this is negative 29 over 16. This is the denominator, all right? So that's our denominator. So basically speaking, our final answer. Our final answer ends up being 21. So we're saying tan alpha minus beta is actually going to be 21 over 8 divided by negative 29 over 16. Then you have a flip, so you have 21 over 8 multiplied by 16 over negative 29. This can go there 2 times. So 2 times 21 is actually 42 over negative 42 over 29. Right, so this is your answer. So the answer is negative 42 over 29. Okay, so basically speaking, you are going to do the same thing for the positive. The only difference is that if you are going to have tan alpha plus beta, for tan alpha plus beta, what you're going to do now is you're going to have a plus here, but you have a minus here. Alright, so and then this is going to be plus, but this is going to be minus. Tan alpha, tan beta, so now this is going to be minus, right? Then this will become minus, alright? So meaning that the final answer will be influenced, right? So can we, so we're now dealing with tan alpha plus beta. I've just switched a bit of some things there. As I said, the part of the numerator become positive, the denominator has a negative now. And we are now finding 3 over 4 minus 15 over 8. This is the common denominator remains as 8, and this remains as 6. 4 into 8 is 2 times 3 is 6 minus 15. Alright, so we're no longer adding as before. Remember before we were adding 6 plus 15, but now we are subtracting 6 minus 15, which is actually negative 9 over 8. Okay, so this is what our denominator is. So we have, so this is plus, so the numerator is now negative 9 over 8, then divided by, we now need to find the denominator. The denominator is going to be positive, so we have 1 plus, this is still going to be 45 over 16. Right, so we'll have instead 16 plus 45, common denominator is 16, so we have 16 plus 45, alright, instead of 16 minus 45, so 16 plus 45 is 61, so we have 61 over 16 as the denominator. So here it's going to be 61 over 16, right, so 61 over 16, then from there, we are going to have a flip, so we have negative 9 over 8 multiplied by 16 over 61. This into that is still 2, negative 18 over 61. Okay, so this is tan alpha plus beta. Okay, so tan alpha plus beta is equals to negative 18 over 61. Okay, so this is negative 9 divided by 61 over 16 and 8, right? Maybe that's basically more visible. Then this is 1 plus 45 over 16. Then we have Okay, so in board, that is what the solution was. Okay. Yeah, so generally speaking, the solution is moving like this. From here, you can go in that side. Okay, that marks the end of this tutorial. Remember, if you've not subscribed, remember to subscribe to the channel so that you always subscribe to the channel. Alright, so have a good day. This ends today's tutorial.